So example 1. So the question is asking us to find the value of Q. So before we solve, it is very good practice that you draw first and label all the information you have, so you know what information you want to find. So first of all, let us draw the flat plate. Okay, this is a cross-sectional area. Given to you, the temperature T1 is equal to 155 Kelvin on this side. T2 on this side is equal to 50 Kelvin. And then the dimensions, the thickness of your plate is given as 25 mm. We change it into meter, so we get 0.025 meter. And then the dimensions for the area of heat transfer, so A, you can find it based on the dimension given, 200 mm times 300 mm. So change it into meter again, so you get 0.2 times 0.3 meter. It is equal to 0.06 meter square. And then you are also given the value of K. K for copper is equal to 385 watt per meter degree Celsius. Okay, so we are using this equation. Q is equal to Ka delta T over delta X. Now we know all the values, we can just substitute all the values to find the value of Q. So Q is equal to 385 watt per meter degree Celsius, and then the value of A is 0.06 meter squared. The value of delta T is 155 minus 50, so it's going to be 105 Kelvin. And then the value of thickness is 0.025 meter. Okay, so remember the unit for Q, the heat transfer, will be in watt. So we have to cancel out all the units on the left hand side, and the only remaining unit should be watt. So let us look at if we can cancel all the units. So we have watt, the unit that we want. Meter can be cancelled out with the 1 meter here. Now we have degree Celsius, and also another unit related to temperature is Kelvin. So if you remember your previous class, last year we have taught you, so this is only for unit conversion. 1 degree Celsius will equal to 1 Kelvin. So if we are using this rule, we can just cancel out degree Celsius and Kelvin. And the other remaining meter here can be cancelled off with this remaining meter. So now you can see here we have eliminated all the units, and the only remaining unit here is watt. So if you substitute all the values into your calculator, press it correctly, and then you will get the value of 97020 watt. Okay, so remember, the correct answer is important, but the unit is also very important. So if you give me the correct answer without the unit, the answer is still wrong. So remember, correct answer with the unit. Okay, so that is how we solve example number 1. If you have any questions, feel free to ask me.